In today's video, we are going to review how to write the equations of different lines. And you've learned two different forms. The first one is slope-intercept form. And slope-intercept form is going to be y equals mx plus b. And we know that m is going to be the slope of the line, and b is going to be the y-intercept. The y-intercept is always when x is 0, so it's always 0, comma b in coordinate form. Then you also learned point slope form, which is y minus y1 equals m times x minus x1. And for this equation, m is still going to be your slope, but we are going to be plugging in a point. So we're going to have some random point, any point on the line, and that x and that y are going to be replaced in where the x1 and the y1 are. So slope-intercept form, from the equation I can see the slope and the y-intercept, hence the word slope-intercept. And point slope, I can see a point and I can see a slope. So if I want to write the equation in point slope form, I need a point and I need a slope. Well, I have 2 points. I can choose either one of those points. So to write things, I need point and I need the slope. I have 2 options for the point. I can use negative 1, 10, or I can use 7, 2. The slope, we know our slope formula. We subtract the y's on top, so 2 minus 10 on top. Subtract the x's on the bottom. 7 minus a negative 1 means I'm adding 1 on the bottom, so that gives us a negative 8 over a positive 8, which is a negative 1. So to write the equation in point slope form, which is y minus y1 equals m times x minus x1, we're going to replace the slope. So our slope we found was a negative 1. We also have y minus y1. We can choose either of those points. So this could be our x1, this could be our y1. So that becomes y minus 10 equals a negative 1 times x minus a negative 1. That means I'm going to be adding 1. So this is one example of how I could write in point slope form. If I chose the other point, this is my x1 and this is my y1, it would be y minus the y coordinate, which is 2, equals the slope times x minus the x coordinate, which is 7. Either one of those equations would be the correct answer for this particular question. Then I want to write the equation in slope-intercept form, given 2 points. So for this, you need the y-intercept and you need the slope, but the y-intercept is not given to us. If the y-intercept is not given to us, we could find the y-intercept, but that's kind of more work than what we want to do. So what we want to do is instead we want to start in point slope form and then change it into slope-intercept form. So we need our slope first. We subtract our y's on top, 4 minus 3. Subtract the x's on the bottom, negative 3 minus a negative 6. It means I'm adding, so 4 minus 3 is 1. Negative 3 plus 6 is 3. Our slope is 1/3. We are going to start in point slope form. I'm just going to choose the first point. It does not matter. You're going to end up with the same answer in the end. So it's y minus the y coordinate of 3 equals the slope, which is 1/3, parentheses x minus a negative, which means I'm adding 6. Once I'm in point slope form, I'm going to distribute that slope, giving us y minus 3 equals 1/3 x. 1/3 times 6 is like 6 over 1, so that gives us 6 over 3, which is going to be 2. So this is going to become plus 2. And then for slope-intercept form, it's y equals mx plus b. So I've got to move this 3 over because I want to get y all by itself. So I get y equals 1/3 x plus 5 is my equation in slope-intercept form. So both times we start in point slope form. If my answer needs to be in slope-intercept form, I distribute my slope and solve for y. All right, let's take this one step further. We want to write the equation of the line in slope-intercept form that is parallel to the given equation. So we want to think back to our parallel unit, And we know that if two lines are parallel, they must have the same slope. So if I want my new line to be parallel to this line, I look at this line and I see that my slope is 3. If this has a slope of 3, then my parallel slope is also going to be 3. So I know that I need two things. I need my point and I need my slope. We just found that our parallel slope is going to be 3. And if we keep on reading our sentence and we're told that it's going to go through the point 4, -1. So this is the slope I'm going to use, this is the point I'm going to use. Then we look back at the directions and we want it in slope-intercept form. So we start in point-slope form, y minus the y coordinate minus -1 means that we're adding 1. Slope of 3, x minus the x coordinate. Now if my directions had said leave in point-slope form, I would go ahead and stop here, but because I want slope-intercept form, I distribute that slope. I want to solve for y, so I get 3x minus 12. Move that 1 over, and we get y equals 3x minus 13. So each time we write an equation, there's two things that we need. First, we need a point, and second, we need a slope. So when I'm writing the equation of the line, this time we want it to be point-slope form, and I want it to be perpendicular to the given equation. So when I look at my equation, y equals 2x plus 8, it's in slope-intercept form. I see that my slope is 2. Perpendicular means opposite and reciprocal. So the opposite of a positive 2 is going to be negative. The reciprocal of 2 is a -1/2. So the slope of my new line is going to be a -1/2. So I need the point. I keep on reading, and it tells me that it wants it to go through the point of -10, -6. Now I have my point, and now I have my slope. I want to leave my equation in point-slope form, which is nice because that's less work for us. So we've got y minus the y coordinate, minus -10 means, or minus -6 means I'm adding 6. Our slope of a -1/2. X minus a -10 means that I'm adding 10. Because we want point-slope form, we are going to go ahead and stop there. And that is our review of how to write equations.